I just wanted to make a quick video of the formula sheet just to kind of give you my big ideas. All right, if it's a payment, you're on this side of the formula sheet, no matter what. So if it's a payment for, like, you're going to put $300 a month away for retirement, it's this payment. So anytime you're saving for a future thing, like saving up for a wedding, saving up for college, saving up for braces, I don't know, but you're saving up for some big purchase in the future, but you're using payments. All right, you're saving up using payments. It's this formula. This is if you want to find the payment you need to save up. So again, these tend to deal with retirement, saving up for college, big goals. And here you want to find the payment you need to get some future goal. Like you want to save up $30,000 for a down payment on a house. How much, and you're going to do it for 10 years. How much do you need to save a month so that you can get that down payment? So if you know your payment and you want to figure out how much money you're going to have in the future, this formula, if you have a goal of we need $1 million to retire on, what should my payment be? This is here. This payment formula is only used for house and car payments, maybe a boat, something like this. This is when you're borrowing money for a house or a car and you want to figure out your payment. That's this guy. Okay, so this side is all dealing with payments. All right, on this side of the formula sheet. This is actually from here and above. Okay, well, actually this guy too. So if we take out this guy is dealing with lump sums on this side of the formula sheet. So if it's a chunk of money, it's a one-time amount. It's not every month you get $1,000 or it's just you inherit $10,000. Boom, one chunk of money. What are you going to do with it? Or you get a bonus at work. They give everybody a $5,000 because of COVID or something. What are you going to do with it? It's a lump sum, okay? If the problem says simple interest, the word simple interest has to be in there. You're going to use these formulas. This one just gives you the interest. This one gives you the amount of money with interest, either way. Time has to be years. So if they give you 5 years, T is 5. If they give you 5 months, you got to use 5 over 12 because T is always in terms of years. Compound interest, again, you have a chunk of money, say $10,000, and what are you going to have in the future? So you want to know how much money you're going to have with interest in the future. You invest $10,000. N is how it's compounded, so maybe it's monthly, it's 12, quarterly, it's 4, daily, if it's a normal year, 365, if it's a banker year, 360. And you just put everything in, hit enter. This is the present value, what you need to invest today to get to this future value. So if you know that you want $50,000 in 10 years for whatever, a wedding, right? Maybe you think your kids are going to get married in 10 years or 16 years old and you're like, maybe when they're 26, they'll get married. This tells you what you need to invest today, not payments, but a lump sum today to get that money in the future. Okay. So maybe you think by the time your kid's 26, weddings are going to be $30,000 a year, right? And so you want $30,000. You know what you can invest it at, how it's compounded, all that jazz. This is going to tell you what you need to invest today so that in 10 years, when your kid turns 26, you have the money saved for a wedding. But it's a lump sum investment, meaning you're going to invest one chunk and let it sit there for however long to build to that. All right, this one down here is also a lump sum. This is only if it says it's continuously compounding. So if it says you invest $100,000, it's continuously compounding at 5% for 20 years. How much money do you have? If that word continuous compounding, it's here, okay? The one that's kind of squished in the middle is this guy. And this is either effective rate or yield or annual percentage yield and annual percentage rate. This is when you're comparing apples, peaches, and oranges, and I don't know, pears. And you want to get the interest rates to be all the same. So if you're doing this formula, what you're doing is you're comparing, like, say, maybe 5.6% compounded monthly with 5.62 compounded quarterly and 5.619 compounded semi-annually. And you're just converting these into different interest rates. Notice there's no money in these problems, so there's no money amount, no dollar amount, and there's also no time. Because your time is 1 year. You're trying to convert things that were monthly, daily, quarterly into annually. That's why it's annual percentage rate. So then you use that formula. So that's when you're compounding that. All right, hopefully that helps you when you use what formula. Again, payments are on this side. This is when you want to know what money you're going to have in the future with interest, but you know your payment. You're just trying to figure out what you're going to have in the future. This is you have a goal and you want to figure out what payment you need to get to that financial goal. This is car payments or house payments. Over here, if it says simple interest, use this formula. Compound interest, this is if you have a chunk of money, a lump sum, and you want to know your money and interest in the future. So, hey, if I invest $20,000 and I leave it there for 30 years, what's going to happen? That's this one. The second one is if you want to figure out what you need to invest today to get to some goal. Oh, I want to have $50,000 to help my kids go to college, but they were just born, so I have 18 years to do it. What lump sum, it's a chunk of money, do I need to invest today so that I have this college fund funded? But not with payments, with a lump sum, chunk of money. This is if I want to compare interest rates, so apples, oranges, and pears, and try to get them all into annual percentage yields. This is if it says that your money is a chunk of money, again, lump sum, but it's continuously compounding. All right, hopefully that helps. Just kind of knowing when you do what, all right? And then I'll make a video on if you want to learn how to use logs to solve for time. And again, at the bottom of the sheet is kind of what everything stands for, and then annually and so forth. All right, here you go.